So what I want to do is get you into the habit, and I really want you guys to get into this habit of experimenting locally in your local VM and saving. Once you've got it mastered, once you've got it down, go and then make the configuration changes for your server on the ESXi. All right? And that's mostly just because it's really quick and easy to rebuild something on your desktop, where we've all seen how much fun the ESXi server can be when we try to shove 3.2 gigs worth of data at a 100 meg NIC card. All right? So I kind of want everybody just kind of get in that habit. Work locally, experiment, figure it all out, and then go from there. What we're going to do is we're going to start actually working on our final. And today's lesson is going to be DNS. So domain name service. It's basically what translates a name, something we can remember like yahoo.com, to an IP address. Okay? The fundamental underlying system for all that is something called domain name service, DNS. It makes up what's something called comprised records inside the database that it has. It's basically a text database that resides on your server. You have the IP addresses and the names of all your boxes, and then you have what's called a forwarder. Anything I don't know about locally, I'm going to send off to our DNS over here at Quest. All right? So we're going to build a forwarder. We're going to build a listener because we need to listen for DNS queries. Right? And then we're going to do a little bit of security because we want to lock it down, because you don't want me going through and pulling everything out of your DNS server. All right, so a little bit of things that we're going to kind of do today. We're going to kind of go a little bit slow, right? Mostly because it's Monday. So first things first, an MX record, mail exchange. MX, mail exchange. That's your email server. So whichever box, whichever IP address you turn into your SMTP server for your final has to have an MX record, so it knows to transmit all the data that's email on port 25 to that particular box. All right? So your mail exchange has its own record in DNS for mail exchange. It also has what's called an A record, an alias record, that's going to be mail.mydomain.com. So I can also look it up, because I have to be able to come through, whether it's a browser or whether it's something else, to actually take a look at what we've got, right? So you're actually going to have something called an alias then, an A record, right? An alias record is the IP address to the name. It's an alias, all right? So the IP address can be anything. The name will basically stay the same. So when you bring up a whole new system, all you got to do is just change IPs, and people won't even notice, because they'll always be going to mail.yahoo.com or mail.mydomainname.com. So an A record is an alias, and that's what transcribes your IP address to a fully qualified domain name. Now there's also something called a CNAME record, a canonical record, mail. So if you're inside your network and you just want to be able to type in mail, mail will then point to mail.mycompany.com or mail.yahoo.com, right? So MX, mail exchange, alias, IP address to a fully qualified domain name, and then a CNAME record, which can be an alias. So if you go to some companies and you type in www, it will take you right to their main SharePoint page, right? Because it just makes life easier, right? So you don't have to remember a whole bunch of stuff. You don't have to remember internal logon, this is really cool.mycompany.com, right? Because geeks are weird, and we'll do stuff like that. So it kind of makes sense on what those records are. What's an MX record? What's an A record, an alias record? What's a CNAME record? Yep. No. What's a CNAME record? It's a shortcut. Yep. Canonical names. Yep. It is. There is no age of consent for canonical names. All right. Our two tools are going to be Bind9 and DNS-Utils. All right. Bind9 is the core DNS package that you guys are going to be working with. All right. So Bind9, apt-get install Bind9. Don't forget the word sudo in front of it. Your utilities, the ones that make it a little bit easier to manage, right? It's just DNS-Utils. So when we get to our handy dandy little VMware, whatever we've got cooking here, so we want to sudo apt-get install Bind9. Bind9. As long as you guys can get on the internet, this should work. Remember your password? and it will come out and say, hey, these new packages are going to be installed, right? So it will install a shortcut of DNS-Utils. It will not install all of them, just so you know, all right? It will give you just a few odds and sods, so that's why we want to go ahead and install the full suite of DNS utilities later on, so we can do this. So sudo apt-get install bind9, your password, and then we want to say yes. And then it goes through and it does its thing, right? Goes through, pulls everything that you need to know about, goes ahead, pulls the package, installs everything, and it's a beautiful thing. It makes its own man pages. It works a new firewall rule, all right? So when you're on the server, you can be following along with me or you can be hanging out and watching. All right, but one thing I want you guys to really watch, right? And this is the really kind of interesting part, is that when it did this, it made a new firewall rule for you. Everybody remember UFW? Unix firewall, the ultimate firewall, the best firewall on the face of the planet, right? When you're running server and you add a package like DNS, it will automatically make a new firewall rule for you. So if you turn on your UFW firewall, that rule will already be in place to allow port 53. What does DNS ride on? What's its two protocols? It's port 53, but it rides UDP first, and then if it's having problems talking, it'll ride TCP. So port 53, UDP, and then if it's having problems, it will upgrade to TCP IP. All right, and then the same thing. Type in the box. Sudo apt-get install DNS-Utils. All right. So according to this, it already says it has the whole 9 yards. Yep, I know it did. It didn't. You normally, sometimes, will not install the full package. So if you go back and verify that it did the entire package of DNS-Utils, this just makes sure the packages are installed right. Right? So I'll sometimes have you do things because sometimes the installer packages from any Unix install doesn't include all the really cool stuff that we want to have. Right? So sometimes it's good to go back and actually check and make sure what you got. All right, where do we keep all of our configuration data? What directory? etc. So there should be a new directory called Bind9. Just bind. So it's just bind. All right. So let's clear this. All right. What we have is called zones now. Right? So bind keys. All right. Then we have DB0, DB127, DB255. So DB0, 127, and 255. What do those numbers remind you of? IP addresses. Darn tootin'. So if I have an IP address of 0, what does that tell me? It's the full network. If I have an IP address of 127, what does that tell me? Local. And if I have an IP address of 255, what does that tell me? Broadcast or local, right? DB empty, DB local, right? DB root, named conf, default zones, named conf options, and then more keys, right? So if we go in and we take a look at, let's just go ahead and poke around in all the keys. What do I have to type if I just want to look inside the file? More? All right. Bind keys used to override built-in DNSSEC trust anchors. All right. DNSSEC is probably one of the more important things to know about, right? Basically what it does is it requires authentication DNS server to DNS server. I'm only going to talk to DNS servers that I know and trust, right? So if you go out and you try to unload everything that's in a Quest DNS server, it should come back and tell you nothing. If you're on the Highline network, it will tell you every device connected to the network, right? Just by using the NS lookup, setting the server, and then doing a directory on it. Right? Everybody remember that from 166? Right? Maybe? So DNSSEC is their way of getting around that. I will only accept updates from servers that I trust. I will only give data to servers that I trust. So you actually have to be part of the process to understand how DNS will work back and forth. That means I can't inject www and then turn it over to myevilsite.com. And that's what DNSSEC is really, really good about. Anybody recognize these from last class? That's your actual key. That's an initial key. An initial key is something that starts the crypto chain. It's sort of like a little seed, right? And that seed, you pass your crypto key, it passes its initialization vector, and then you agree on a bigger crypto key. What's the problem with an initialization vector that's part of open source software that everyone knows about? Everybody knows about it, right? So if I already know half the key, how hard is it for NSA to break into this? Not very. How hard would it be for any other hacker to break into this? Not very, right? So if you know half the crypto key, it makes your key much easier to figure out, right? It makes it a little bit easier to inject. So you could actually cut a new key for this if you wanted to make sure that you were actually running on your own keys as the initial seed vectors. Does it make sense? So DB0, right? So DB0, bind reverse data for the broadcast zone. And when you get your networks built up, this will be one broadcast zone. So you guys remember how to subnet, right? Anybody here forget how to subnet? I'll send you over to Chin so he can have you relearn how to subnet. All right? So your local broadcast zone. The broadcast zone for this classroom is 255, so it's Class C, right? It's a Class C network. So in here, time to live, 604, 800 milliseconds is about 7-ish days, right? About 7-ish days. Every timing sequence that you do in DNS is based on seconds. So just so you know, right? This is my root. In, start of authority. Start of authority tells this DNS server what it's responsible for. So you're going to be rack6 cis217.highline.edu. And then you'll have mail.rack6.cis217.highline.edu. Because the guys upstairs get really, really annoyed if we just say if we're mail.highline.edu. They'll get really tweaked out because of the way DNS is built here at Highline. It actually injects that record and we become the mail server for the college, which then really ticks people off. All right? If we called our start of authority highline.edu, all of a sudden every single computer in this network would go, oh, you're the new DNS server, cool. And then we'd be trying to reroute all of Highline's DNS through this network, and that would just be ugly. I mean, like really, really bad. So when you're making your start of authority, your rack 7, your rack 5, you're in CIS217, then your highline.edu. Right? So your start of authority is going to be rack 4, CIS217, highline.edu. And you can actually go in and make these manual changes. One, serial, how often do I refresh this? Right, in seconds? How often do I retry until I bail out on the entire exchange and say, forget it, I'm not finding it? Right? A retry basically says how many times I'm going to keep on trying to find myevilsite.com until I give up and say, okay, myevilsite.com doesn't really exist. I have no idea who it is. Right? Expire, I'm going to expire anything that's in this database at the end of something like a month. So if it's not used, if no one ever goes to myevilsite.com and it's a record stored in the database, it will just expire it out because no one ever goes there because I didn't set myevilsite.com up correctly. But if I own your DNS, this is a really, really cool thing. So DNS has got a lot of security around it, right? We want to make sure we're talking only to people that we trust, right? And then negative cache time to live, same amount as the refresh. Negative cache time to live is basically how long do I store all those domains that I don't really use anymore, right? And then we have @in_ns is name service. Name servers are the other part of it. You're building a name server. That's what DNS is in computer language. And basically, it's a name service, right? So what file in your SE directory contains all your name services? Do you guys remember which one that is? Nope, shadows your password hashes. Which one of those files we looked at in 215 has all of your name services in there? Yep. All right. So it says that my local host is in my name service. Now, right now, you're running what's called a zero configuration DNS, just by the state of installing it. Right? You're actually running a zero config. So it will service stuff for you, but every time you make a DNS request through the server you just built, it will forward it onto Quest, because you've basically set up your network to use the Quest DNS. So this is called a zero config. Your DNS server will work right now for big global things, but it won't know who mail.r6.cis217.highline.edu is, right? It won't know Joe, Bob, Nancy, Jim. It's dead Jim. It won't know who any of these are. And this is what you're going to put in here as you kind of go through this. All right? More DB.127. Okay. Resolve conflict file. All right. 127, same thing. 255, same thing. Just to be aware of that. Right? DB.empty, same thing. You're going to see some redundancy here, right? Now, here's the interesting part. Your db.root file. All right, so the internet has what's called root DNS servers. There's something like 24 of them now that are global. There's 3 of them that are in the United States. There's a bunch in Europe. There's a bunch in Asia. These are the root servers. The root servers know who everybody is. They know where all the bodies are buried. They know every single domain on the planet. So they know where Yahoo is, and they know where AWS is, and they know where this highline.edu is. So they know where everybody is. If in doubt, your DNS server will query and keep on going up the chain. So if you're looking, if you type in nslookup.myevilsite.com, right, it will go and look at its local database and go, okay, I don't have a cat, I don't know who myevilsite.com is. And then it will hit Quest, right? And Quest will go, okay, who's myevilsite.com? And if Quest don't know about it, it will send it up to AT&T. And if AT&T doesn't know about it, the resolution of last resort is the root server. And then that will propagate down from root to AT&T to Quest down to your server, myevilsite.com, right? If you go in here and you muck about with this, you can really screw up someone's day, right? So if you set up a DNS server and you pop yourself in and change all these root servers over to your IP address, you've basically broken the chain of where everything goes and how DNS works up and down the tree, right? So good for hacking if I put my own IP address in here as primary for the root server. Bad if you guys go ahead and do it and make yourself a root server, because the internet won't recognize that at all. All you do is really frustrate your users, and on sometimes that's a lot of fun to frustrate your users, but in other cases, most people leave the root files alone, right? We don't go in here and muck with it, because that's how it builds its dependency tree all the way up to the Lord High I Know All. And if myevilsite.com isn't in there, they'll say no such site found. DNS name wasn't able to fully qualify out. Name.conf local. All right. Any local configurations here? Anything you want to do locally for configuring your DNS server goes here. All right, and we'll get there as we kind of go through this for the day. All right? More zones.rfc1918. RFC1918 is the standard. All right? This is where we get RFC1918. If you actually want to go read it, if you're suffering from insomnia, this is a beautiful thing to read. Okay? I guarantee you, first couple of pages, you guys are going to be out like the lights. But RFC1918 basically governs what happens with DNS. So what you'll see here is you'll see some zones. right? Type master file etc bind db empty. So anything that's an empty file. So if it sees something that starts in 16.172 and address ARPA, because we have to do forward and reverse, and we'll go over that here in a minute, right? It's a master. The file's in etc bind9 db empty. If there's nothing in the db empty file, where does it go? It goes to Quest. If Quest doesn't know about what's in that IP address, it goes to AT&T, then it goes to the root server, and then back down again. And everyone caches that. So this is kind of a pointer for where you want to go and how you want to do stuff. So kind of interesting. Muck about with this file at your own peril. All right? If you change anything in here, because you're going to run into instructions and say, oh yeah, just change your RFC 1918 file. It won't hurt anything. For the love of God, if I want to make a copy of a file before I go in and start editing the bejesus out of it, what do? I make a copy. I make a copy big time, right? Every time you go in and you edit one of your DNS files, make a copy, right? And one of the best ways to do it is to do, if you're working in your 127 file, right? Just put a minus sign followed by the date that you worked on the file. That way we can kind of back things up a little bit and we know where everything went. And you know that if a change was made on 2.14 and all of a sudden on 2.15 nothing worked, you can revert back to the changes on 2.14. So it kind of gives you a way of backing everything up, right? And you know that if a bad change was made, that you can kind of go through this and then go back and approach it. All right. Did I cover all the major files? We're going to make zones here in a minute. Yeah. So when you guys were in June's class, did you guys actually configure DNS on the Windows boxes? You know what a forward IP zone is? You know what a reverse zone is? Did you guys go over that in Chin's class? No. Okay. Well, then we're going to cover that in here. The standards between Windows and Linux are pretty much so the same, right? So if you know what a forward zone is, a reverse zone is in Linux, you're going to know what it is in Windows DNS, right? They look almost pretty much so the same, right? The only thing that's really going to be different is going to be how Windows approaches the subject with a nice, beautiful graphical user interface, and how Linux does it with a beautiful, wonderful command line and black screen and white text, all right? So let's go ahead and let's take a quick break here for a minute, because I've got to go look up stuff on forward and reverse zones, so I know to make sure that I teach you guys right. So let's go ahead and take a quick break, like 10 minutes. Go grab a cup of coffee or something, and we'll come back to this. DNS is dangerous. All right? So what we're going to do is we're going to work in what's called the named.conf.local file. So what I'm going to do is I'm going to copy named.conf.local to named.conf.local, and then today's date, what is today's date? 13. Lucky. 1/13/2014. All right, because this is when I'm making changes. And this is just kind of, this is my own bad habit, right? So I'm going to teach you some of my bad habits as we go along, but I'm going to let you know that it's my own bad habit that I'm teaching you. All right? So I just do stuff, and then I got to be root. All right. Yeah, the file that I'm editing, I just put the date when I made the edits at the end of whatever my backup is. I would like you to learn some of my bad habits, and this is going to be one of them, right? And again, it just kind of keeps it easy that if someone comes in and makes a change later on, you know when your last good thing was. Yes, so you can go back and take a look at it. My bad habit is when I edit a configuration file like this, where everything is really dependent on it, I put the date I made the edits on the backup, right? Yes, sir. I can't, because I've only got one screen, and I need to be able to have both the web browser and the VMware going at the same time. So unfortunately I can't. All right, so sudo nano name.conf.local, right? And then what we want to do is we want to make a zone. So we want to go zone. 2 slashes in this means that it's a comment. Zone. All right, here's what I want you guys to get used to doing. So, your zone, if you are in Rack 4, is Rack 4 CIS 217 highline.edu. You are in Rack 7, Rack 7 CIS 217.highline.edu. Rack 2, Rack 3, Rack 4, Rack 5, Rack 6, right? So I want everyone to get used to that. Because if you pull the zone and you say I'm highline.edu, then again, you're going to route everything in the entire campus through your computer, which would be bad. If you say you're instructor.cis217, if you typed in everything that I just typed in, then you and I are going to be duking it out on the network level trying to figure out who's really the start of authority for instructor.cis217, right? And then the computers will get confused. And when computers get confused, what ends up happening? We all die. We divide by 0 and everything crashes. So, right, you're going to be Rack 6, you're going to be Rack 7, Rack 4, Rack 5, Rack 2. Now the other thing I want you to do as well is because we're working on a test box, I want you to put your name in the front of it. Right? So if I was in Dan.instructor CIS217, that way I don't have 4 people saying you're all rack6.cis217.highline.edu. Right? Does that make sense? So I want you to be the start of authority for yourself. Because if we do it any other way, if I have 4 people trying to be Rack 6 or Rack 5 or Rack 2, then the computers will start duking it out. Right? If you put your name in it, because we're just using our VirtualBox locally to test, then we don't have the computers duking it out on the network. Because if we have the computers duking it out on the network, what ends up happening? We divide by 0. What happens when we divide by 0? Everything goes Hades in a handbasket really, really quick. All right. Now what we want to do is we want to be indet1 and we want to be type master, right? And then a semicolon. All right. And what that means is we want to be the master DNS for dan.instructor.cis217.highline.edu. We want to own that domain. That's our domain. These are the things that I will own as a computer service. It's a semicolon. So bring that up a little bit. You know, you could be kungfumaster.rack6.cis217.highline.edu, and I would be perfectly fine with that. I really would be. Type master, and then where do we store our file? Where do we keep all of our stuff? Etsy, bind, DB. And we're going to be really kind of weird. We're going to go instructor. CIS217. And we want to remember that name, right? And then a semicolon, and then the end of a curly bracket, and then another semicolon. All right? So that's our name local file, right? So we've made a new zone, right? That's dan.instructor.cis17highline.edu. This is a long, ponderous DNS name in comparison to something like Yahoo or Bing or something else, right? We are the master for this domain, dan.instructor.cis217.highline.edu. And then where we're going to store all of our stuff, our files, is going to be Etsy, bind, DB, instructor, CIS217. All right? And then we want to save it. All right. So what I also need to do next is I need to touch a file. I don't mean that to sound kind of crude, but we need to touch it. All right? What do we need to touch? We need to touch the individual file that we just pointed everybody off to that doesn't exist. So I want to touch db.instructor.cis217. All right, just want to make a blank right now. Yes, sir. Okay. But I get permission denied. Why? Because I have to be sudo. We're going to get... Okay. Is everybody caught up? Does everybody have all this really, really cool stuff? Yep. So you've got your rack numbers on this one. All right, so is everybody with me? Now, that touch file is empty, right? There's nothing in there. And then the last thing I want to do is type in all the stuff that actually goes into a zone file, because that would just be ugly in terms of time, energy, and all the rest of it. So what I can do is I can go sudo copy. Yes, sir? It's curly brackets. It's a curly bracket. And then a semicolon. Sudo set cp etc bind. And then I want to use a db.local as my master file, right? To db.instructor.cis217. All right? So I want to copy the DB.local, and I want it to shove all the contents into that file I just touched. Is everybody good? Everybody with me? Everybody got it? All right, yeah. All right, so is everybody with me? Are we good? So then you should have your DB instructor CIS217 or john.r7.cis217.highline.edu, however you wanted to do it. So it kind of makes sense? Are we good? Everybody with me? Are you happy? Is this like the most wonderful Monday you've ever had on the face of this entire planet ever? Almost. What can top DNS? What do you mean almost? Sleeping in, that's like so Sunday. All right. Sudo nano db dot your file name. All right. So what we want to do is we want to edit this bad boy now. And then there's all of our stuff in there. So in start of authority, it says localhost, root localhost. So that's our localhost bit, right? What's our localhost tell us? That's our what port? 127001. There's no place like home. Geek humor. What is our localhost? What does that tell us? That's our machine. Loopback port. So that's your, what's the Ethernet interface number for that? Yep. So ETH0, all that kind of good stuff, right? So what we want to do now is we want to start doing stuff to make this thing happen, right? So you want, at the end of it, just put at the end of it, right? TTL, and then let's go ahead and leave it at 60, oops. Number lock, make sure your number lock is on. 604,800. All right, so we want to have our timeout value in here, correct? Everybody with me? Everybody typing this in? You all excited? All right, then at in SOA, and we call it dan.instructor.cis217.highline.edu. All right. So we have to put in NS in front of that because this is our name service, right? NS, name service. So @in start of authority name service dan.instructor.cis217.highline.edu. That's a mouthful and a half, right? So it's kind of unwieldy, it's kind of bulky, right? Then we want to add a new line to that. We want to do root.dan.instructor.cis217.highline.edu. And then we hit enter. So what ends up happening sometimes is that if your lines are too long for the buffer when you're working inside of Nano, it will just shift everything over while you're still typing. It's all there. You just need to make sure when you see this little $sign thingy here, that means that there's more data to follow on, right? So you got to make sure you're typing when you kind of go through this. So we've now set our start of authority. Anything that starts with dan.instructor.cis217.highline.edu or root, I'm the root server for that domain, dan.cis217.highline.edu, right? So that kind of makes where we begin. So if I had a mail exchange, I could do mail.dan.instructor.cis217.highline.edu, right? If I had a database and I just wanted to call it db.dan, right? All these little things, I can kind of go along with it, right? But this is where we're set up that this is where I'm responsible for. Anything that belongs outside of that, I don't know anything about. I don't care. I don't want to know. I want to have nothing to do with it. It's Sergeant Schultz, right? That's that whole process. All right. So tab over twice. When you get back in here, tab over twice. So underneath that, we want to set this up to be our second most important thing that we do. So our local host is still second on the serial port because we don't really care about serial. Then we want to go semicolon and we want to call it serial. All right? So that's our line right underneath that. So that's not part of the line above it? Nope, no, we're on new lines now. Then 604.800, we want to call it our refresh. All right? And 86400, colon, semicolon, retry. What does retry mean? Do it again. All right? Then 2419200. What does expire mean? All right. How many times am I just going to try to keep it before I get rid of it? Yeah, roughly. What you got to do is divide seconds into hours, into minutes, into hours, into days. And I just don't really feel like doing the math right now. So, right. Then our next number is 604.800 again. And then what do we have here? Right, we have our other curly bracket. And then, and what is a negative cache? Well, that's because I had to put a curly bracket here on the bottom. Sometimes it's not going to be purdy.
Does it matter?
No. No, it does not matter. This is a matter of purdy and making it so that a real human being can actually read it. Right? Because sometimes we like real human beings. Sometimes. Not always, though. All right, so at the bottom of this, we need to start making what's called our records, right? So, when we go in, we make a semicolon. Then we go @in NS. So remember our name server, right? It's going to be ns.dan. All right, so that sets our name server, right? @in Name service is ns.dan.instructor. That's who we got. Right? So, at in an A is an alias record, right? We can do 127.0.0.1. That will point all of our name services back to our local loop, right? And we can do that, and we'll do that for right now, because we just want to see if things work or not, right? At in AAA records, that sets our area, our authoritative answer area. Huh? Quad. All right, I meant quad. All right. Then NS in an alias, and then the IP address of the box that we're working on. Right? So, did everybody grab their IP address? All right. So, we make a name service record to point off to our name server. We make an alias record for our local loopback. We make our authorization, authentication, authorization record to point to our specific box, right? .1 equates nomenclature-wise to 127.0.0.1. And then we do name server in A, an alias, for the actual IP address of the box that we're currently on as our name server box. Yes, ma'am?
You're saying currently we're on a virtual box. So
You would use your virtual box IP address. Yes, sir. Those are colons. Yeah. No, it's all right. How many people are going to watch the video later on tonight? How many people really, really hate me right now? And this is like, why on God's green earth would you hit me with DNS at 8 o'clock on a Monday morning after the Seahawks won, and oh my God, I'm still feeling the beer.
No, honestly, it's awesome, but I mistyped one thing, and by the time I looked up, you were already like 2 steps ahead.
Yep.
I figured I'd just watch.
All right. All right, so everybody's got this? Are we good? We want to save it. All right. So we'll leave this up here for a minute so you guys can kind of see what we got, right? So we have our local host, right? And then we have dan.instructor.cis217.highline.edu. So how many people need this up for a couple more minutes? Because we have to restart DNS now. And serial is basically one of the ways it works through the system, right? It serializes everything in Linux. And if we want it to serialize what's going on inside the DNS database, then we'll specify serial for that IP address. All right. If we did this right, sudo etc init.d. Anybody remember what that is? Bind9 restart. If we did this right, if I made no mistakes, I should be able to do sudo etc init d bind9 restart. I'm going to restart DNS because I need to read that configuration file now. All right? So, how many people want to put... Oh, I've only got one Starbucks gift card on me, so... And it failed. Huh? I have a typo in my conf local file. Well, we can only make things so big. So, all right. So you're saying in my what file? This guy? Yep. Hey,
You need a semicolon.
they got the semicolon there. All right. See, typing. DNS will kill you every time. All right. So there we go. Okay. No, honestly, you guys are going to spend, we're all going to spend a lot of time doing that. All right. Don't feel bad about this at all. Sudo etc init.d bind9. Yep, that was it. That was just a typo. So I'm good. So I am now the authority, the start of authority for my domain. Unless someone else put something else, the same thing. Unless someone typed exactly what I typed, and now we're going to be duking it out to see who's the instructor bit. All right? Well, no, it's just funny. If you bring up Wireshark and you start looking at the network packets, now that you've all installed DNS, you're going to see all sorts of DNS resets crossing this room like you wouldn't believe round robining, right? Because we've set up DNS on the network, and now it's going to announce itself to the world. I am your DNS server. And someone in Building 30 is probably losing their mind about now. What the heck? We just set up DNS. No, they know I do this every term. And they hate me every term. All right. So, while it's still fresh in your head, redo it. All right, if you got questions and all the rest of it. But no, while it's still fresh in your head, what you want to do on restart is make sure you get okay. And again, even I'll do typos, so don't feel bad about typos, right? It happens. But I want you guys to go ahead and have DNS up and running before you leave here in the next 50 minutes. Or at least as close as you can to getting it up and running. So back out all the changes you made. You don't have to deinstall it, right? But we want to go from 0 config to our master. Right? So I want you guys to get used to doing this. So you all ready? Are you all prepared? Do you want me to just leave this up on the board? All right. Then we're good. Replay the video right now.